Okay, we are starting topic 5 next week, and the first thing we're going to talk about is slope-intercept form. Some people may already know this from last year, it just kind of depends, but we will review it and talk about expectations on it because there's a lot of different ways to do it, and I want to make sure that you're showing your work and that you understand what everything is used for. So we're on page 28. We're going to use both the left and the right side of the pages today, so 2 pages of notes. All right, slope-intercept form is the title of the notes, and for some people it's 11:30, and for others it is the 1st of December. And the learning target is I can find slope-intercept form from various representations, so different ways that the problem could be represented. So as usual, we're going to start with some vocabulary so that we all know that we're on the same page. So firstly, slope. First part of the word, or first part of slope-intercept form is slope. So I wrote an M here because that is the variable we use to represent it. So we don't want to be using M for other things during this unit because M will exclusively be used for slope, and it's lowercase. And this essentially is the measure of the steepness of a line. So how steep a line is the slope, okay? And now you should be going, oh, we've used steepness of a line before or talked about it, and that's because it is related to rate of change. It is the constant rate of change shown in a graph or a situation. So constant, it can't be changing all the time for it to be slope. And lastly, that it's only for linear functions, meaning lines. So if it's a curve, there is no slope. Okay, has to be a line because remember, constant rates of change form lines. Okay, so that's all connected. It's just taking it a step further than the last topic. Then we have intercept, or more accurately, y-intercept. The intercept we're referring to in the title here is the y-intercept, or the lowercase letter b. Okay, I know it can look like a 6, but we're supposed to use lowercase letter b, so we need to use that. Now this is where a line or a curve crosses the y-axis. So notice this time I wrote line or a curve because lines or curves can cross the y-axis. As long as they cross the y-axis, that's the y-intercept. Okay, it intercepts the y-axis or crosses it. Okay? And it can also be known as the starting value or starting point of a situation. And so we'll see that when we look at like verbal representations. And then the other way to think about it is the y value when x equals 0, which would be the point 0 comma some number. The number can also be 0. The origin can be the y-intercept. It can be a negative number. It can be a positive number. It doesn't matter. But that's the way that the y-intercept will always be written because on the y-axis, x will always be 0. Okay? All right. Then we have actually, I know there's a lot going on over here, but let's just focus on the word part first. So slope-intercept form, and what that means is it's one way to write an equation for a line. So notice that it's only one way. There's going to be other ways to do this that are equivalent. Okay, you can take the one line and write it in multiple ways. Or you can call it like a function rule. So it's an equation that represents the situation or the line on a graph. So here is what it looks like. I guess it's a lot lighter on the video, but you can see I kind of put a teal line around it. That is slope-intercept form, y equals mx plus b. So you might be going, oh, I have seen that before. And here's the rundown of it. Okay, so firstly, when we officially write y and x, like give the official answer, y and x are going to stay letters, okay? And that's because they represent all points on the line, right? A line is really just infinitely many points all squished together so they form a line. So these need to be a placeholder. And when you plug in any point for x and y, it will be true, which we'll actually do an example, not today, but at a later day in the unit. Then we have m, which represents the slope. And I like to say it's how we move because M and move starts with the letter M. And B is the y-intercept, and that is where you begin. Because if you think about it, the starting value or starting point, that's the beginning. Okay? So what happens is when all is said and done, you might have to do stuff to this equation. You might have to plug stuff in for x or y to find m and b. But once you find m and b, you need to rewrite this, and you only plug the numbers in for m and b, and you leave y and x alone. Okay? And you'll see when we go over some examples. Then we have what's known as the slope formula. So there is a way to find slope. There's lots of ways to find slope. One is through the slope formula. And you're going to, again, want to memorize this, and you're going to want to memorize this. So the slope formula says that the slope through a line containing the points, meaning these are just 2 points from a line, is, and then I have this here. So first I want to focus on this. So notice that I wrote these. X always comes first in a point, and Y always comes second. But notice I wrote these subscripts. They're called subscripts because they go down low. They're not like an exponent where they go high. And that has no actual mathematical operation to it. It's a label. So what I did is from this first point, this blue one, I labeled them with 1s because they come from the first point. So I'm actually going to write here first point. And then this other one over here, I used the subscript of 2 because I'm labeling them as coming from the second point. So that when I see this x with a 1 and I see this x from a 2 with a 2, I know that they're from different points. So this is from the second point. Okay, so now that we know that, we put them into this formula. So remember, slope is like rate of change. So m equals, or slope equals, change in y over change in x. That's one of the ways we talked about rate of change. Well, a way to find this is by subtracting them to find the difference. So you take the y values, because change of y is on top, and you do the second y value minus the first y value, divided by the second x value minus the second or the first y value. Now notice I tried to make those minus signs really thick because it's always a minus sign, okay? It's always built in that way, and so if there's a negative, then you'll have minus a negative number. And so we'll go over an example here. It says, find the slope of the line passing through the points for -2, so you can see there's a negative number there, and 0, 5. Okay, so notice I wrote those in 2 different ways on purpose because it's kind of 2 ways of saying the same thing. So here it says the line contains these points. Here it says the line passes through these points. That means the same thing. These points are on the line. If it contains it, it's on the line. Okay, great. So the first thing I'm going to do is make one of these my first point and one of these my second points. And I will always label it because it makes me feel better. So if this one's my first point, and you can choose whichever one, I just say it comes first, so I'm going to choose it to be my first one. Then this is x sub 1 and y sub 1, okay, because it's the x from my first point and the y from my first point. Then this one must be my second point, so I'm going to put x sub 2 and y sub 2, because this is the x value from my second point and the y value from my second point. Great. So, you know me, I like to write the formula down. So, you should have it memorized because then you can just go, okay, m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So, notice how the sub 2's both come first. Those are both from the same point, and the sub 1's come second. They're both from the same point. Now, all I have to do is take each of these, and I want to double, triple, quadruple check as I'm doing it to make sure that I put each number in the right spot. So, I'm going to put the fraction line, just so it's there. And we have y sub 2. Well, y sub 2 is 5. Okay. And then remember, the minus sign is built in. So, minus. And then my y sub 1. So I'm going to go over here and just double check. My y sub 1 is -2. Remember, this is a subtraction sign that has a -2. So I'm going to put parentheses -2. Okay, because that's 2 separate things. Then I have my x sub 2, so I'm going to go over here, and that's 0. And then my minus is just part of the formula, so it has to be minus. And then my x sub 1 is 4. Okay, so I just wanted to make sure I'm putting everything in the right spot, because firstly, you have to memorize this correctly. People are going to want to put x's on the top. Don't do that. But here we have it. Then we actually perform some, whoopsies, hopefully that's not blank for you. We'll find out. Okay, we perform the actual math. So we do 5 minus negative 2. Well, minus a negative, remember, becomes plus. So I can change this to be 5 plus 2 over 0 minus 4. Okay, then let's do the actual math. 5 plus 2 is 7 over 0 minus 4 is negative 4. And again, you can use a calculator as long as it's not on your phone. You should download the one for your Chromebook if you haven't already. Okay, so it looks like this, but sometimes if you flip these points, someone else's might look like this with a negative 7 on the top and a positive 4 on the bottom. So see how the negative went from the bottom to the top. That is actually the same answer. This and this are considered to be the same. And in fact, so is negative out front and then 7/4 by itself. So notice, as long as you only have the one negative, all of these are equivalent and you can be flexible. You can put it out front, you can put it in the numerator, you can put it in the denominator. Personally, I always like to put it out front or in the numerator, but that is fine too. So all three of these are actually the same answer and they are all correct. Okay, it just depends because your friend might have chosen to make 0,5 the first point. There's no problem with that. You're allowed to do that. Okay? So that is how you use the slope formula. Okay, so before we get into writing it on our own, I want to make connections to the graph because a lot of our explanations were connected to the graph. So it says how to graph from slope-intercept form. So normally what we've been doing is we've had a table and we had to plot the points and determine, oh, does that look like a line? Okay, great. Well, now that we have slope-intercept form, we can actually do a little bit of a shortcut to figure this out. So remember that these are in a specific form and that M is our slope, and I'm color coordinating. I'm using the same color I used for M up here. Okay. So in this case, M is equal to negative 1/4. Now, remember how when you have a negative, you can put it anywhere you want? Well, I'm going to move it so that the negative goes up top because, again, that's my preference, is either out front or up top, and you'll see why I want to put it in one location in a second. So this becomes negative 1/4. Okay, and lastly, because this is like rate of change, we know that I've used the saying rise over run in terms of rate of change, right? Rise over run. So it's the same thing for slope because slope is essentially rate of change if it's constant. Now, what does that mean in this context? Well, since I put my negative in the numerator, that means that my rise is negative 1 or down 1. Okay, and my run is 4, or in this case, right 4. And I always just like that bottom to be a positive number, but that's what it means. If it was positive, it goes to the right for run. If it's negative, it goes to the left. Okay, make sure that you don't take this negative and put it with both of the things. If there's one negative to start with, when you move it, there still can only be one negative. Okay, then we have, again, color coordinating, my B value. So my B value is, again, where do you begin? And I'll just write this over here, B equals positive 2. Okay, so since that is my y-axis, or my y-intercept, I'm going to go on the y-axis to positive 2. So I'm just going to say that this is all scaled by 1, so I don't have to do the tick marks. If you scale it besides 1s, then you do have to show the scale. So I'm going to go up to 2 on the y-axis. And that is because my y-intercept is b equals 2, or 0, 2. Okay? So remember, those are the same thing. So I just want to make sure you're seeing all the different ways. Now, that is where I begin. Then from there, I'm going to do how to move using my slope. So again, my slope is telling me that from my starting point, I need to go down 1, and then to the right 4. 1, 2, 3, 4. Okay, and then that is where my new point is. And then same thing, from that new point, go down 1, and then to the right 4, right? 1, 2, 3, 4. So 4. And that gets me my new point. But oh no, I ran out of room. Well, once you run out of room, you can go backwards. But how do you go backwards? So, when you run out of room, I like to say, reverse, 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 reverse. You know, like the song? Maybe not like the song? I don't know. And what that means is to take both of your actions from the slope and reverse them. So I have right now M is down 1, right 4. Well, to reverse that, I need to do the opposite or the reverse of both of those things. So that means my down 1 becomes up 1, and my right 4 becomes left 4. And that is all the same. So you're allowed to reverse it as long as you reverse both things. And that's why I like to use the song, because it says reverse, reverse. We're doing both of them. So if I'm going to go reverse, and I'll use this new color here, then I'm going to go back to my starting point and go up 1 and back 4. So 1, 2, 3. And that is my new point. And again, from that new point, I can again go up 1. Ooh, right to the end of the page. Okay, and if I've done this right, this should form a line. And I'm going to use red, because red will stand out better. Oops, than whatever I got going on here. Lots of different colors, you know me. Okay. Yeah, that looks good. And now I have, and then put arrows, because the only reason we stopped was because we ran out of room. But this line technically goes forever. You could just go down 1, or right 4 forever that way, and up 1, left 4 forever that way. And the line would just keep going. So you put arrows on the end, and there you go. So that's like my little shortcut. Okay, let's do the same thing to this one, and this one has some special cases, which is why I wanted to make sure that we included it. So now, again, I'm going to use my colors. Here, you'll notice if when I go to find my number in front of the x, x is not part of the slope, so you can't use that. So what number goes here? Well, when you don't see a number, we put a 1. Because there is 1x. So that is what the slope would be. But unfortunately, that is not it, because we have more to do. So firstly, we know m equals 1. Well, this one over here was a fraction, and this one is not. So we figured out one problem, what's this number, to to now have a second problem, which is, well, what is the rest of this? Well, that is another thing. Besides putting a 1 here, you can put any number over 1, and now I have a fraction. So all numbers can go over 1. Okay, so anytime you don't have a fraction, like if you had the number 7, well, make it 7 over 1. If you have the number negative 12, make it negative 12 over 1. Ta-da, you have your fraction. So this time I don't have to deal with any negative, so I can just go straight into rise over run. Well, my rise is 1, which means up 1. And my run is 1, which means right 1. Okay, so up 1, right 1, up 1, right 1, so on, so on, so on. And now the tricksy part here is for the B value where we begin. You can't ignore this negative. Over here, I included the positive 2, but I didn't have to talk about it. That's easy. But here, if there's a negative, you need to make sure to make it in our B value. So that means I need to come over here to our y-axis and go to negative 3. 1, 2, 3. So again, this is B equals negative 3 or 0, comma, negative 3 as a coordinate plane. Okay, and I'm going to keep doing that too because people like to forget about it. All right, then once we have our beginning point, we know how to move. Up 1, right 1, put a point. Up 1, right 1, put a point. Up 1, right 1. And once you kind of get the hang of it, you don't have to keep doing those little stairs anymore. You can just keep going up right 1 until you run out of room. Then to go backwards, we do reverse, reverse. So since it's up 1, it's going to be down 1. Instead of right 1, it's going to be left 1. So I'm going to start at the beginning point again, and this time I'm going to go down 1, left 1, down 1, left 1, down 1, left 1. And again, once you kind of get the hang of it, you can just do it on your own. Ta-da. Okay, and now, so notice again, you need to make your graph going all the way across the given grid. Okay, I kind of went off a little bit over here. I went down too far, but that's fine. I'd rather it go more than is necessary than not enough. Then what we do is we make sure that those are lined up. Again, if they don't line up, especially between your backwards and your forwards, then you've made a mistake. So we line them up, we put a line through it, and add arrows to show that it goes on forever. And ta-da, we have graphed our line. So, little shortcut to that, okay? And you will get to practice that in class. Now what we want to do is use various representations to give us, or for us to write y equals mx plus b, or slope-intercept form. Okay, so now we're going to be writing slope-intercept form, which again is y equals mx plus b. I just put it up here so that we wouldn't have to flip back and forth between the two pages. So we're going to do it from various forms. So you can see I have like from a graph here and from a table here. So I'm going to just ignore from a table for a minute and focus on from a graph. All right, so from a graph, we again are doing y equals mx plus b, and we want to put in an m value and a b value, or slope and y-intercept. Well, hopefully y-intercept is very easy, because where does it cross the y-axis? Well, right here. Whoopsie daisies. So that means that the y-intercept is b equals, and then again, I'm assuming the scale is 1, is -1. And then we can also say or 0, comma, -1, because again, I want you to be so used to that you can do it in your sleep. Okay, so there's the first thing. That's B. We got B already. The second part is the slope. And remember, we can use slope as rise over run for a graph, just like rate of change. Again, slope is essentially rate of change, but only for constant rates of change. Okay, same thing. So you can pick any 2 points, because I gave you a couple points here, here, and here. And we just need to calculate how much it's going up or down and how much it's going over. So here, we're going up, so it's +2. And then we're going right, so it's +3. So the rise is +2, and the run is +3. Again, you don't need to write the positives because they're already implied. So from here, all I need to do is I'm going to bring this down here. Y equals mx plus b. And for the official equation, you only put in the m and the b. The y and the x stay y and x. So slope is 2/3, so I'm going to put that in for m. And so I'm going to have y equals 2/3 x. And then you could write plus -1, but since I already know that it's negative, I'm just going to write -1. And then there is your answer. That's it. So I think that if you have a graph with whole number points for the y-intercept and stuff, that is like the easiest way to do it, and you're done. Easy peasy lemon squeezy. Okay? It's the reverse of what we did before. Then we have from a table. So from a table, we're going to have actually a couple options, which will be nice. But the first thing I want to do is find the slope. So remember, slope is like rate of change, and rate of change can be found by change in the dependent variable over the change in the independent variable. Okay? Well, this side is the independent variable. This side is the dependent variable. Don't forget it. So if we come over here and we see that the change is +2, then +4, then +2 again, and then +10, dang. Okay. And then over here we have +1, and then +2, and then +1 again, and then +5. Okay. But here is the dealio. When I grab my calculator, okay, when I grab my calculator, remember, these should be a constant rate of change. So actually, when I look at this, they're all going to end up being the same. So make sure to do the dependent variable on top and then the independent variable. So the first pair, remember, it has to be the same side, or like between the same 2 points. So that's going to be 1/2. Okay, which is 0.5. Then the next one we have 2 and 4. It's 2/4, 0.5. Here again we have 1/2. Well, we already have done that. And then we have 5/10. And that is 0.5. So notice that even though those numbers look different, it yields the same thing every time. So we can say that this is, 1/2 if we just use the first 2 numbers. Or we could say 0.50. Now, the only reason I'd say 0.50 is because it's cost in money, and money is 50 cents. I'm actually going to leave it as a fraction, but you could do either. But when in doubt, leave it as a fraction. Okay? So, either one of those. Okay. Now, here's where I'm saying we have 2 options. So we have 2 options for finding the b value. Well, how do you find the y-intercept on a table? Okay, so the y-intercept, remember, is when x is 0. So if we go backwards in our table to make x equal to 0, right? That's where the starting place would be. We see here that we have to minus 2. Well, when you minus 2, or when you added 2, you added 1. So to go backwards, you have to undo -1. Okay, because it has to be the same matching thing. Since +2 went with +1, -2 goes with -1. Just like if we were to, how we add 5 here, or 10 here and add 5 here, if we were to subtract 10 here, we would need to subtract 5 here. They are paired together, they go together. So we do 1 minus 1, and that's 0. So that is our B value. Okay, so that is one way of finding the B value, is to essentially go backwards in your table until x equals 0, and the corresponding y value is the B value. Another way to do it, so I'm going to call this option 1 for B. Okay, that's option 1 for finding B. Let's do option 2 for finding B. Which is to use y equals mx plus b. Okay, so what does that mean to use y equals mx plus b? Well, we take y equals mx plus b, and we know what m is. M is 1/2, so you can put that in there. And then you can pick a point here to put in for y and x. So pick a point for x and y. Okay, so let's just say I'm going to pick the point. It literally doesn't matter, guys. I'm going to do 10 and 5. Sure. You just need to make sure that they are a pair together. Don't pick 5 and then like 2 or something like that. So make sure you plug in the right one, that 5 goes in for y equals, and then m is 1/2. And then remember our parenthetical promise that now I have a second number being plugged in. I'm going to use parentheses. And that x value is 10. And then lastly, plus b. So essentially what we're going to do is you can solve or kind of guess and check to figure out what that's supposed to be to make this true. Okay, so I know that 1/2 times 10 is 5. Well, then what does this number have to be to make this true? Must be 0. Okay, because 5 plus anything else won't be 5. It has to be 5 plus 0. So look, even when we did it this way, we got b as 0, and when we do it this way, we get b and 0. That is good, because then we know that that must be the right answer. So then we take this, and now that we're going to write the official form, over here I replaced y and x, but here I will not. I'll only replace m and b. So y equals, and then instead of m we have 1/2 x, and then plus 0. Now, one thing I want to point out though is that if you look closely at this table, I actually give you some alternate things for function notation. So you can use those as well in your, I don't want to use orange, in your equation, and it will have the same structure, but it will look a little different. So this and this can be used for C of t equals 1/2 t plus 0. And this is function rule using function notation. Okay, because I used the c of t, which is in my y column, so I use that for y, and my t is in my x column, so I use that for x. Other than that, it's exactly the same. Okay? Now, don't worry if that confuses you. We won't be doing that quite yet, but you want to be able to do this. And again, we will be doing lots of practice. So give me a second before we move on to the next example. Okay, next here we have when we're given 2 points. So literally what they'll do is just say like, here are 2 points, find the equation of the line that passes through these or contains them. Just like I said before, there's different ways to phrase that. But you'll notice here that I added tried and true. And that is because almost every other problem can actually be boiled down to 2 points. Here, I could have just picked any 2 points on this line. Here's a point and here's a point. Write the points and use this method that we're going to use here. Here, there's a whole bunch of points, 2, 1, 4, 2, 8, 4, and you can just pick any 2 you want and use this method. So the reason it's tried and true is because it is always a good one to fall back on that will always work, even if it's not necessarily like the fastest way to do it for a particular problem. So first things first, we need to find the slope using the slope formula. So find slope using slope formula. Okay, so find the slope using the slope formula. And we have already said that that is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, something you will want to memorize. Obviously, I already have it memorized because I'm old, but you know. Then what I'm going to do is pick one of these to be the first point and one to be the second. And again, it doesn't really matter, so I'll just make the one that comes first, the first one. So negative 24 is my x sub 1. Negative 5 is my y sub 1 because they're from the first point. And remember, x always comes first in an ordered pair. Then that makes this one x sub 2, y sub 2. So then from here, what we want to do is just make extra sure that we put the right things in the right spot. So y sub 2 comes first. If we come over here, that is negative 1. Okay, then I'm going to put a minus before I even look at the next thing because a minus is built in. And notice that I made that orange because it's not from a point. This negative 1 is from this point. The minus is from the formula. Then I'm going to come over here and my y sub 1 is negative 5. Again, since it follows a negative, I'm going to put it in parentheses just so I don't get confused. Okay. Then I go on to the x's, x sub 2. If I come over here, that's an 8. And then again, I'm not even going to look at what comes next. I'm going to put a minus sign because the minus is just part of the formula. That's why it's orange and not one of the other colors. And then my x sub 1 is negative 24. Again, since it's minus and then a negative 24, I'm going to put it in parentheses. Okay. Awesome. So I like to take the next step and rewrite this with changing the double negatives because we don't want double negatives. So we have negative 1 and minus negative 5 becomes plus 5 over. And then 8 minus negative 24 actually becomes plus 24. Awesome. So then from here, we just do the math. And again, feel free to use your calculator. If you use a calculator that looks like this, okay, the negative sign is this one way, way down here by enter. It's not this one. That is the subtraction symbol, and it will give you an error if you do that. So if you tried to do negative 1, oops, negative, oops, see, it won't even let me do it. It just keeps putting answer. So that's no good. You have to use this negative 1 plus 5, and you get 4. Okay, so that is 4. And then 8 plus 24 is 32. Now, this can actually reduce. Again, we're not going to spend too much time focusing on reducing in your head. If you can, great. But again, the calculator will do it for you. So you do 4 divided by 32. And oh no, that gave me a decimal. Well, if you do math, and then see how it says arrow fraction for number 1? Hit enter, and then it turns it into the fraction for me. So this is simplified as 1/8. Pretty slick. I'll post those and other calculator hacks as we go through this unit. Okay, so there's my M. Boom. Okay. Now that we have M, we need to find B. But again, this isn't on a graph and it's not in a table. So how do I find it? We're going to use the same method as right here, which is to pick one point and plug it in and try and figure out what B needs to be to make it true. So that's number 1. Number 2 is going to be to pick a point and plug into y equals mx plus b. Okay, because we want to find B. That's our goal. We don't know what B is. We want to find it. So it doesn't matter which one you pick. I'm going to pick this one because it at least has one positive number. So I don't want to use that color. Let's use 0 or 8 comma negative 1. Okay. So that means when we look at y equals mx plus b, the first number is our x value, that's the 8. Our second number is our y value, which is the negative 1. So literally you're subbing or plugging it in. So the y becomes negative 1 equals the m becomes 1/8. Parenthesis, because of our parenthetical promise, and the 8 goes in for x. I'm literally just replacing, and then plus b. Okay, so from here, you need to at least multiply those two things to find out. Again, feel free to use a calculator, but 1/8 times 8 is actually just positive 1. This is negative 1 plus b. So essentially, we need to figure out 1 plus what is b. Well, 1 plus nothing, right? We want to subtract something. It should actually be, and again, you can use your calculator to figure that out. 1 minus 1 is 0. That's not right. I want to get negative 1. 1 minus 2 is negative 1. So that must mean that b is negative 2. So you can guess and check for this too, or you could solve if you know how to solve. Okay, so now I have my b value and my m value. So step 3 is just to put it all together. Okay, so you have y equals mx plus b, and now that we're actually giving our final answer, remember, we actually don't put anything in for y and x. We leave them alone and only put stuff in for m and b. So y equals m is 1/8, x, and then since b is negative 2, we write minus 2. Okay, so there's that one. Again, like I said, it's not the prettiest method, but it will always work. And again, you can guess and check for this, and it's okay. You say, well, what number makes that true? And that will be your b value. Okay, so now we've done given 2 points from a graph, from a table. The last one is verbal. The problem with verbal is that there's lots of different options. So let me get a second to set it up, and then I will show you. Okay, so now verbal, I have a couple different options because they can all be written in different ways. So the first one, option 1, is like the easiest one, and that's if they give you a starting value, or b, and a rate, m. Well, there you go. That's the slope and the intercept, so you'd be ready to go. So an example of this would be that Corey starts with $100, and he adds $60 every month. Every 2 months, sorry. So I now have a starting value here. So this starting value is my B. So B equals 100. Now, over here, he adds $60 every 2 months. That is a rate, okay? And you can think of it like he adds $60 per every 2 months. This essentially helps us form a fraction because remember, it's numerator per denominator. So that means my M is going to equal $60 over 2 months. Okay, because again, think of every and per as interchangeable, so numerator per denominator. Well, I can actually simplify that because 60 divided by 2 is 30. So that means M is 30. Now I don't need to carry the units because I can't put the units into the equation anyway, so I'm going to drop them and just use the number. Then from here, all I do is put those into the equation. So y equals mx plus b, and I do y equals, and for m, I replace it with 30, and then x, plus, and then 100, because it's positive 100, so plus 100. And there you go. So notice how your starting value and your rate of change just fit right in there for slope. Okay, so that one's super easy, and you would love to get it in, especially if it told me just $30 per month, then I could have just put the 30 in there, but I had to do a little bit of solving. Then I have option 2. Okay, option 2 includes a little bit of given 2 points, and you can use it one of the options from writing a table. So again, this one, you're given a starting point, which is B, or a starting value, but you're not given the slope, you're given a point. Okay, well, let's do this. So I'm given this value here, which is my starting value. So you starts with $100. This is my B. Okay. Then I am given a point, okay? And so let's say that point is 3 months, $190. Well, that becomes 3, 190. Okay, so that gives me a coordinate point. Once I have this and a coordinate point, I can plug all of those into the equation. You plug in what you know and use that to find your missing value. So then let's get a something color. Well, hot pink is fine with me. Plug in what you know into y equals mx plus b and find remaining value. Okay, so that's what we're going to do. We just did it up above, not the last one, but the 2 points where we had to find b. We've only found b, but now we're going to find m, but that'll still work. It'll still be great. So we have y equals mx plus b. Well, I have my y value is 180 from my coordinate point. So I'm going to replace that, 190. Replace that with 190 equals, I don't know m. My x value is 3. So I'm going to put parentheses around it, parenthetical promise, because m3 means nothing. So it's m times 3. And then plus, and then my b value from way up here is 100. Okay, so again, you can use guess and check, or you can solve. It's up to you. So if you use guess and check, you just plug things in here until you get 190, that side to equal 190. Or you can subtract 100 from both sides because you have to do the opposite. I didn't mean to cross that out. 190 minus 100 is 90. Equals m times 3. And then the opposite of times 3 is divide by 3. So then we divide both sides by 3. And 90 divided by 3 is 30. So m equals 30. Great. So now we use that to put into our formula. So y equals mx plus b. I know that m is 30. So y equals 30 x plus, and my b is 100. And there you go. Okay? So again, with different information, I'm able to get the same exact answer. Okay? And then I saved the third way for the most difficult way. But again, notice it says when given 2 points. So when you're given 2 points, essentially you have to create the 2 points, but then you can come back up and use this method. Find slope using slope-intercept form, plug stuff in to find your b value, and then write it and put it together. Okay? So here we go. If I'm given 1 month, it says after 1 month of saving, Corey has $130. So 1 month, it gives me $130, which gives me the point 1, 130. Then I have, after 3 months, Corey has $190. So that gives me the point 3, 190. Okay, and so from here, I can use the slope-intercept form. Not that. I can use the slope formula to find slope. Okay, so the slope formula is m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Again, memorize it. So I can pick whatever I want up here. So I'm going to make, again, since this one just comes first, I'm going to make this x sub 1, y sub 1, and then this one I'm going to make x sub 2, y sub 2. So y sub 2 is 190. So 190 minus, and then y sub 1 is 130 over x sub 2 is 3 minus 1. Okay, 190 minus 130 is 60 over 3 minus 1 is 2. 60 divided by 2 is 30. So my m value is 30. Then what I want to do is find my b value. So to find my b value, I'm going to plug it in, what I know, into y equals mx plus b and find the remaining value. So just like I did over here. So let's see. Plug into y equals mx plus b to find b. Okay, so remember, if you look above, it says that we have to pick one of the points. And again, you can be either, you will end up with the same answer. So I'm going to use 130, it doesn't matter. So I'm going to use 130. So I have y equals mx plus b. My y value is 130. My m value is 30. My x value is 1 plus b. Okay, and I can do 30 times 1. That's 130 equals 30 plus b. So what do I need to add to 30 to make, whoopsies, hopefully that wasn't dark for too long. Oh boy. Okay, sorry guys. So here I plugged in, I just did 30 times 1 is 30. Now I ask myself, what 30 plus what will get me 130? Again, feel free to either solve by subtracting 30 from both sides or do guess and check, and you'll see that you have to add 100. So B must be 100. Okay, so then that means I can now put it into slope-intercept form. So 3 put into y equals mx plus b. Okay. Kind of trying to organize this because I don't have much room. So sorry guys. Y equals mx plus b. So now m is 30. So y equals, put in 30 for m, and then x, and then plus 100 for b. And that's it. There you go. So now I know you're probably like, dang, that's a lot of ways. It's really important you get these down because we're going to use them to structure our solving our examples. So I'll go, okay, let's look at this. What does it say to do here? What does it say to do first? And we'll follow that. Then we'll go to the next one and go, okay, now let's go to the table because it's a table. What should we do first? And we'll use these to figure out how to write the slope-intercept form. Okay, so make sure you do these before. I hope you have a good Thanksgiving break, and I will see you soon. Bye.